Welcome to the PhysicsPlace, the place to learn about physics, and in this video I'm going to explain how you can calculate with horizontal projectile motions. And it's very important that you already have seen the video about vertical projectile motions because we will need that information to continue. In this situation we have a guy throwing a water balloon and the motion will look like this. So the water balloon will first go up, then go down, and all the time it will also go forward or to a certain direction. So we have two kind of displacements here. We first have the horizontal displacement or the horizontal motion, which we can calculate with the horizontal speed multiplied by the times. So we have the displacement, which we can get by multiplying the horizontal velocity in meters per second with the time in seconds. Besides that, we also have a vertical motion because the water balloon is also going up and down. And for that we have a different equation, and that's this one. For the vertical motion, like my previous video, we can calculate with the vertical speed, the initial vertical speed, multiplied by the times plus a half times g, and g is the gravitational acceleration, which is 9.8 meters per second downwards, meters per second square downwards, or upwards, downwards, so it can be a negative or a positive number depending on the motion. And you have to look out, because if we are looking at the vertical motions, we have two different motions. First we have the motion up until the balloon is here. There, the speed, the vertical speed will be 0 because it will be at its maximum height. And after that, it will go down again, and then it comes here with the original speed it had when he was leaving here, but then the other way around. So if he had here a vertical speed up of 5 meters per second, here it's 0 meters per second, and here downwards it's 5 meters per second again. And you have to look out, so this has two motions, so it's a motion up and then a motion down. And the thing that these two have in common with the horizontal motion is that the time it takes for the balloon to go up and down again is the same time that it takes to take this horizontal displacement. Another example, you fire a gun horizontally to a target 120 meters away. So you fire the gun and the target is 120 meters away, and the bullet has a speed of 450 meters per second, and that's the horizontal speed because you were firing the gun horizontally. Calculate the vertical displacement of the bullet when it hits the target. So it will be displacing vertically, so it will go a little bit up or down, and you probably know which one it will be after the gun has been fired horizontally, and we have to calculate how big that displacement is. So first we have the horizontal displacement, we have the horizontal speed, and we have the gravitational acceleration, which is minus 9.8 meters per second. And we have the initial velocity for vertically, which is 0.0 meters per second because the gun was fired horizontally. And we have to use this equation to find this vertical displacement. And therefore we need the time. So we need to know how long this bullet traveled. And we can get that information from this equation because we do have the horizontal displacement, we do have the horizontal velocity, and we can calculate how long it will take the bullet after leaving the gun to hit the target. And if we know how long that takes, then we can also calculate how much time it has to go downwards with the gravitational acceleration of minus 9.8 meters per second square. So first we have to calculate the time. Therefore we need to rebuild this equation. So we have the displacement divided by the speed. We have them both, so 120 divided by 450 is 0.267 seconds. That's the time it takes the bullet from your gun to hit the target. So that's not a lot of time, and it will go down a bit, and we can calculate what the displacement will be with this time. So we will now use this equation. We have the initial velocity, which was 0, multiplied by the time, because that's given here, plus a half multiplied by minus 9.8 multiplied by 0.267, and of course the square, that's the time, equals minus 0.35 meters. So the minus meant it went downwards. If it would be a plus, it went upwards, and that's not the case because of gravity. It will be going downwards all the time, and it's going downwards 0.35 meters. So that will be the vertical displacement. And the final example, this is a difficult one. You throw a rock from a roof of a building which has a height of 26 meters. And you throw it with a horizontal velocity of 21 meters per second and a vertical velocity of 7.9 meters per second. So you don't only throw it horizontally, but also vertically, so also first up. How far will the rock land from the building? So you have to calculate the horizontal motion, and you have to calculate the horizontal displacement. Therefore you need the horizontal velocity, which you already have, and the time. And the time is difficult now. You can get it from the vertical displacement, and you have to remember it will first go up, and when it's at the highest point it will go down, and it will also go down a little bit more than where it started, because it will go down 26 meters more because you were already on the building. So we also need this equation, the vertical motion, and we need to use it twice. First to calculate how long it will take the rock to go up to the highest point, and then to calculate how long it will take to drop from the highest point to the ground. We add those two times together, and then we know the total time of the motion, and then we can calculate the total horizontal displacement. So we have the beginning height, so we have 26 meters, we have the horizontal speed of velocity, and we have the initial vertical velocity, and we have of course the gravitational acceleration, which is minus 9.8 meters per second, because first the rock will be going up, which is a negative to the acceleration. And we first have to calculate how long it will take the rock to go up, because we need the time for this equation. Well, for that we use this equation. We have the change in velocity because we start at an initial vertical velocity of 7.9 meters per second, and when the rock will be at its highest point, this one will be 0. So we go from 7.9 to 0 with a certain acceleration. The a here, the acceleration, is equal to the g here. We need to rebuild it because we need to calculate the time. So again, we use this equation. We can swap these two. So we can swap these two and it will look like this. So we go from an initial vertical acceleration of 7.9 to 0, so that's minus 7.9, and we have an acceleration of minus 9.8 for that, so that will take us 0.806 seconds. So after this time the rock will be at its highest point, and now we have to calculate how high that point will be. So we use this time for this equation. So the initial speed multiplied by the time plus a half times the acceleration, which is negative because we are going in a different way than the accelerations. We are going up, this one is going downwards, and multiplied by the time and the square, of course, and we now know that the maximum height will be 3.2 meters higher than where you were. So now you know that it took you 0.806 seconds to get this highest point. So the first motion we now have the time it took for the rock to come at the highest point, and now it will go from the highest point downwards to the ground, so plus the 26 meters, with a certain acceleration here. So we can again use this equation, but now with a little bit of different height, because we are already a little bit higher, 3.2 meters. So I have written down the time here and already the extra height. So now we can calculate how long it will take for the rock to hit the ground. This is the equation. We have the displacement, which is 26 meters because we were already on the top of the building, plus the 3.2 which it just got by going up. So that's the displacement, the vertical displacement. We have an initial velocity of 0 because it's at the highest point, so it has no velocity. Multiplied by the time, we don't know the time yet, that's the one we are going to calculate. Plus a half, multiplied by 9.8 because now the acceleration is going in the same way as the motions, multiplied by time in the square, and we don't know the time yet, so that's the one we actually need to calculate. This one added together is 29.2. These are discarded because 0 times the time is 0, plus a half times 9.8 is 4.9, and we have time in the square. We divide by 4.9. And now we have the square root, so we now know that it takes 2.45 seconds to go from the highest point to the lowest point. And we already know how long it took to go to the highest point. So we now know that in total, the whole vertical motion took 3.256 seconds. So first going up, it took this time, then going downwards, it took this time. So in total, the rock was in the air for 3.256 seconds. And now we can calculate the horizontal velocity. Yes, I know this is a very difficult example. So now we can calculate the horizontal velocity because we have the horizontal time multiplied by the time the rock was actually flying, and it's 68 meters. So the rock will go first 0.806 seconds up, and it will gain a vertical height of 3.2 meters. Then it will fall down to the ground in 2.45 seconds, so the total motion is 3.256 seconds. And if you multiply that with the horizontal speed, which was constant, 21 meters per second, we have 68 meters further from the building where the rock fell on the ground. That's it. I hope you now know how to calculate with horizontal projectile motions. If you found this video helpful, please let me know by liking and of course subscribe for more videos. Thanks for watching.